Hi friends, today we discuss need for biasing for a transistor. So the biasing is the process of providing DC voltage to which helps in the function of the circuit. So here the DC voltage is provided to the transistor. So this transistor is functioning in the circuit. So we don't give the DC voltage to the transistor doesn't functioning properly in the circuit. So that's why we need biasing. So here transistor can be used as amplifier and as switches. For the case of amplifier, so here the collection, here we provide DC voltage as follows. Emitter base junction is forward bias, means input terminal is must be forward bias, and the collector base is reverse bias. So output terminal can be must be provide reverse bias. So in this condition, the transistor can be used as a amplifier. Next, transistor must operate in octave region. So here we already discussed in a DC load line or output characteristics of a transistor. So here there are three regions. So one is cutoff region and another one is saturation region and middle part is the active region. So we get the proper output in the output region. So transistor must be operate in the active region. So otherwise we get some distortion in the output or some part of the input cannot be amplified in the output. Next point, the input voltage must exceed cut-in voltage. So here the transistor is a semiconductor device. In the transistor we have two junctions, so emitter base junction and the collector base junctions. So here emitter base junction is in forward bias. Emitter base junction is in forward bias and the collector base junction it is reverse bias. So emitter base, middle one is base and the C means collector. So this junction is forward bias. So it is forward bias. So the depletion region between the emitter and base junction must be eliminated at the voltage of 0.7 voltage. So we don't give the 0.7 voltage to the this junction. So there is a presence of depletion region. The transistor doesn't work. Means it is in off conditions. So that's why we must provide 0.7 voltage to the this junction. Okay. So that's why we need a biasing for a transistor. So here there is a circuit. So you can see here the circuit. So here we use two batteries or DC supplies. So this battery is in reverse bias and this battery is in forward bias. Okay. So next we discuss operating point. So operating point means the point which is obtained from the values of IC or VCE when no signal is given to the input is called the operating point. So here means no signal. No signal means so absence of AC signal. So absence of AC signal. So the connection like this. Here we connect battery VEB to directly to the emitter terminal and the base terminal. So here the AC signal is removed. So in this condition, so there is a graph between IC and VCE. So here IC is varies linearly with VCE. Varies linearly with VCE. So at the zero signal, means absence of AC signal, the operating point must be lies in the active region. So this operating point is depends on IC and VCE. So I repeat, the point which is obtained from the values of IC or VCE when no signal is given to the input is called operating point. So for the amplifier, the operating point must be lies in the middle of the active region. So in case the operating point is shifted towards the saturation point or shifted towards the cutoff region, so we get the output is in distortion form or clipped form, or some of the region, some of the part of the input signal is cannot be shows in the output. So that's why here the operating point must be lies in the active region. So the DC load line is like this. So this is along x-axis VCE and along y-axis is IC. So this is the output characteristics of a transistor. So here IC is varies linearly with VCE. So there is a graph between IC and VCE, we get the straight line. So this is called the DC load line. So this part is called this part is called saturation region, and this part is called the cutoff region, and this part here to here is called the active region. So in these regions, the operating point must be lie in the middle of the active region. Okay, next, factor affecting the operating point. So first one is temperature. So here the transistor is mainly made up of semiconductors. So in the semiconductors, when the temperature rises, the conduction will be increases. Why conduction will be increases? Because these semiconductors is made up of using covalent bonds. Here the atoms means silicon and other doping atoms is bonding with the covalent bond. So this is a very weak bond. So here when the temperature is increases, the bond will be breaks. So when bond will be breaks, the valent electrons is move towards the conduction band. So here when temperature increases, the free electrons is becomes more and more when temperature increases. So that's why when free electrons increases, the current will be increases. So next, here there are three important parameters will be affect due to temperature. So first one IB. First one is IB. So IB means base current. So here IB increases, IC is also increases. So from the graph, so here IC, so here VCE and IC. So this is the load line, DC load line. So when IB is increases, so IC also increases. IC is also increases from the relation IC is equal to beta times IB. So here operating point is depends on IC and VCE. Operating point is depends on IC and VCE. So where IC is increases, VCE is decreases. So here this Q point, So Q point is called quiescent point or silent point or nothing but operating point. So this point is shifted towards the saturation region. Okay. So next, beta. So beta is called the current gain. So beta is equal to IC by IB. So beta is equal to IC by IB. So it is called current gain. So this beta is also affected due to the temperature. And VBE. VBE. So here VBE means voltage across the base and emitter junctions. So when temperature increases, the voltage across the base and emitter junction will be decreases. Here every 10 degrees Celsius of temperature increases the ICBO is the reverse current. Reverse current is gets doubled. So when ICBO increases, so IB is also increases, and IC is also increases from this relation. You can see here. So this is IC. So when ICBO increases, IC is also increases. Okay. And every 1 degree Celsius of temperature increases. 1 degree Celsius of temperature increases. So VBE is decreases of 2.5 millivolts of voltage is decreases for every 1 degree Celsius of temperature increases. Next, stabilization. So what do you mean by stabilization? So here the operating point is sensitive to the temperature. So when the temperature increases, the operating point is also increases. So when the operating point is increases, we get the distorted output in the amplifier. We get the distorted. So clipped or clamped waveform we will get, or some part of the input signal will be lost due to shifting the operating point. So stabilization means the process of making operating point independent of temperature change or variation in transistor parameter is called stabilization. So I repeat, the process of making operating point independent of temperature changes or variation in the transistor parameter is called the stabilization. Okay. So the operating point must be constant, must be stay some point or middle of the active region. So irrespective of temperature changes, or so variation of transistor parameters is called stabilization. So variation of transistor parameter. So we know the transistor for various companies. For example, for S100, beta is nearly or equal to 100 times 100. For BC547, the beta is nearly 300 above. 300 above. So your beta is very much different for the different transistors. So that's why, in case in the circuit, the transistor can be replaced due to some reasons. The operating point must be constant or must be lie in the active region. So it's called stabilization. So why we need stabilization? So here the Q point changes, we get the distorted output in the amplifier. Next, need for stabilization. So here temperature dependence of IC. So here temperature dependence of IC. So here temperature dependence of IC is called the stabilization. So stabilization means the process of making operating point independent of temperature change or variation in the transistor parameter is called stabilization. temperature dependence of IC. So so here when the temperature is increases, IC is increases. So here IC increases, the Q point is shifted from active region to saturation region. So that's why we need stabilization. Next, individual parameters like IB and beta. So these IB and beta depends on the transistor. So for different transistor and different companies transistor, the beta and IB are different. So in the case of replacement of transistor in the circuit, so the Q point must be changed when replaced. Next, thermal runaway. So it is very important. So here when temperature is increases, IC is increases. So when IC is increases, so this current is also produces some temperature. When IC is increases, the temperature of the transistor is increases. So it is called thermal runaway. The self-destruction of such an unstabilized transistor is known as thermal runaway. So that's why we need stabilization. So thank you. So in the next video we discuss biasing circuits.